Welcome everybody to this Friday afternoon office hour. It's nice to be talking about something this time of year that isn't extreme heat and wildfires, and today's focus will be on the highly unusual August low pressure system along with cool temperatures and even some meaningful precipitation up in far northern California and across most of the Pacific Northwest. That'll be the focus today. A few other disparate thoughts that have popped up, questions from journalists over the past few days, and some global climate related headlines that may or may not be accurate or contextually meaningful. And also wanted to offer some thoughts about what might happen in the slightly longer term with fire season. Obviously, up in far northern California and the north coast, rain this week means that there isn't much of a fire risk at all for at least a while. But what does the rest of the state and the rest of the season look like? Because, of course, California has a much later shifted fire season than many parts of the West, which in some coastal regions, which is, again, where most people in California live, within about 50 miles of the LA basin and the San Francisco Bay Area, fire season often doesn't peak until September or October, and I expect that to be true this year as well, meaning that we're not done yet. Although the weather right now is not conducive, at least in California, for fires. And one other thing I wanted to emphasize in this conversation today is that it has been an extremely active wildfire period just east of California. So in the Great Basin in Nevada, as well as in Idaho, Montana, and Wyoming, where numerous extremely large and fast-moving fires are burning partly as a result of the trade-off with this weather pattern bringing cool and wet conditions to parts of the west coast, brings very dry and windy conditions to the continental interior, which, like California did earlier this season, also experienced record-breaking heat in the weeks and months leading up to the present. So I want to offer some context for all of that today. Just a reminder that this channel is partially sponsored by REASK, a climate risk company rethinking Earth system risk in a warming world. And I think that probably most folks want to hear about today are the clouds, the rain, and the cooler temperatures, and so I'm going to jump right to that. It is currently in certain parts of Oregon, Washington, and far northern California raining. Which is not typical for really any part of August. August in some parts of California is the driest month of the year. In fact, that's true for a pretty wide portion of the state outside of the southeastern deserts. The far northern portion of California, so the mountains above the north coast, even in August do tend to receive some precipitation. So believe it or not, there are some parts of the coast ranges up in far northern California that have an average monthly August precipitation over an inch. So some precipitation in that far northern portion of the state is not super unusual along the coast. It does become more unusual as you go inland, though. But even there, the amount of rain that will have fallen this August will be unusual, which I think is generally good news from an ecosystem and fire risk and people not liking extreme heat perspective. And so let's talk a little bit more about that. So I think I want to share the screen right off the bat because there's some interesting visuals today. So bear with me for a moment. You're going to see my entire display briefly before I toggle over to what I actually want you to see, which is this. Actually, let's start with instead some live satellite imagery. So obviously this is an image of northern California and northern Nevada, northern and central California, I guess you'd say, and most of Nevada perhaps, as the frame is a bit wider than I believed. But what you can see pretty clearly here is, and I'm going to bring out my screen drawing tool here, there's a lot of clouds over northern California right now. There's different kinds of clouds depending on where you are, and this is actually a really nice example of rather benign weather that is nonetheless quite interesting from a process perspective. So one of the things you can see in this region here are some high-level cirrus clouds. So these are ice particle clouds, ice crystal clouds up at the top of the atmosphere, high levels of the troposphere. And the message. I forgot to share the right thing. Excuse me, there was that one button that I forgot to show. All right, apologies. All right, well, so cutting to the chase then, now that I believe, yes, I think you're seeing what I need you to see. I do need to figure out a smoother transition between these. But for now, that's the wrong tab here. Okay. Apologies, folks. So we have this nice, at the moment we have, let's bring up my drawing tool again. So there's these nice cirrus clouds, these high-level ice crystal clouds, sort of at the base of a trough. So the trough, sort of stylized version of it anyway, sort of thinking about the low pressure being up here, and the flow at the base of the trough over central and northern California looking like this. This is where the upper level winds are flowing across central California. We don't normally see this pattern in August. This is more of a fall or winter pattern where we would see a trough in this sort of position, bringing clouds and some precipitation. But the high-level clouds are mostly following sort of where the jet stream is. It's not a super strong jet streak in absolute terms, but in terms of what we normally see in August, it's fairly impressive. But what you can see also is that there's some other movement of clouds. If you look at these small pockets of isolated cumulus clouds, and I'm going to clear this so it's a little bit more obvious. But if you can kind of think of the large-scale upper-level winds doing that, that was not the best arrow, but I think you get the idea. You can see that there's some up-valley and upslope flow with these weak, shallow cumulus clouds on the east side of the Sacramento Valley and the Sierra Nevada foothills. So you can see that there's some wind shear because the upper-level winds are moving like this and the lower-level winds are moving like that. That means there's some warm and unstable air being advected from south to north up the valley in this fashion. This is a classic pattern that we tend to see the development of thunderstorms, which we already did. A line of them yesterday developed up in the North Valley, brought some heavy rain up to places by Redding. Could see an additional line later today or tomorrow develop up in this region. And generally, I'm expecting to see some meaningful precipitation north of about this line in Northern California. So if you're from about the mid-Mendocino coast up in the northern quarter or northern fifth or so of the state, up in this region north of that line, you could see some substantial precipitation over the next 24 hours. It won't be that heavy everywhere, but the best bet is probably along the north coast and including the North Coast Mountains. And then again, in this region, sort of in the northeast foothills, right where the Park Fire has been essentially in places up there and including Redding, because again, this upslope flow is going to really contribute to some moisture convergence in that region. So here, over the west, over Eureka, Arcata, mid-Mendocino coast, this is kind of a more of a stratiform precipitation mostly. But as you go inland and it's warmer and the air is more unstable, and you have some up-valley flow, there could be some thunderstorms with pretty good downpours. So this will be a period of showers and isolated to scattered thunderstorms across this region. And in particular, again, because on the Park Fire, I believe this is approximately where the Park Fire was. Yes, it really was almost that big. The Park Fire up in this region is under a flash flood watch from the Weather Service in Sacramento currently, because of the risk of not necessarily widespread heavy precipitation, but the possibility of somewhat localized but quite intense downpours if a thunderstorm does park itself, so to speak, over the Park Fire footprint later today or tomorrow. So that is a possibility. It's not super likely, but it is possible. And if it happens, there could be some flash flooding, even some debris flows in this recent fire burn area. It is a very much of the Park Fire footprint is in fairly steep terrain and also has a lot of exposed watersheds. So right now, all of these areas are recently burned, including much of the watershed within the past month. And upstream of there, watersheds burned in the Dixie fire a couple years ago. So there's a lot of burned area, including a lot of recently burned area. Could be some heavy showers or intense thunderstorm downpours locally over the burn scar over the next 24 or 36 hours or so, and that could potentially pose some issues. Generally speaking, in Northern California, from speaking with the geologists up north at the USGS, the risk of debris flows is not as high as it might be down south in the transverse ranges following wildfires because of differences in the soil characteristics and in the steepness of the terrain. Some of the highest debris flow risk in general, but especially in the post-fire environment in the world, is in Southern California in and near the transverse ranges, because those are very steep mountain ranges that are almost exactly at a 90-degree angle to the winds that drive so much of the heavy precipitation down there. And the soil characteristics, the substrate itself, is more conducive to eroding in a way that can produce these highly energetic, very high mass slurries, concrete-like slurries of ash, silt, and water that can comprise debris flows in Southern California. We still do get debris flows sometimes in the post-fire environment in Northern California, but they often are a little harder to trigger and don't tend to be quite as big. What we see a little more of in Northern California instead are just plain old flash floods, which can be just as destructive as debris flows. They just have somewhat different geophysical fluid characteristics, if you will. So up by the Park Fire, would not be surprised to see some flash flooding occur, or some landslides, rock slides, whatever you want to call them. Geophysical instability, slope instability, flash flooding in broad terms over the next couple days. And that will probably be a concern heading into the winter as well. Usually we don't see as much of a concern in August, but of course this is an unusual weather system. So I want to zoom out a little bit. I'm going to hide this for a moment, zoom out, get a slightly bigger picture about what this weather system looks like, bring back my drawing tool. And again, the center of circulation here is very obvious. I think most people probably could have drawn this on a map. Classic low pressure system with the flow around it looking like that. So you can see that there is a broad area of showers and thunderstorms lifting northward across the interior west. There is, as I mentioned, there's these high clouds over Northern California. There's rain and ongoing thunderstorms over the portion of western portions of Oregon and Washington. So these areas have gotten a nice soaking in recent days and are getting another one. You can also see, though, that this pattern is pushing major wildfire activity. So if you look in here, these are major wildfire plumes right now. You can see erupting in Idaho, and in recent days there have been a number of major fires all across the Great Basin in northern Nevada, all across western Idaho, and even into eastern Oregon and Washington. So although I think that the rains we've seen recently and up through the present may well be fire season ending, I would say maybe north and west of a line like this. Let me make that last on the screen a little bit longer. Essentially drawing from the east side of the Cascades all the way, including a small portion of northwestern California. The rain we're seeing this weekend, the rain we saw last week, is likely to severely mitigate, if not functionally end fire season in this region. It's been pretty wet. Some places will be over an inch or maybe even a couple inches of rain in a 2-week period in August. And that might be all she wrote for fire season up there. Once you get north of the California border anyway, fire season along the west coast tends to end earlier because the onset of the rainy season is earlier, and we don't tend to see offshore winds blowing in this region as late in the season as we do in California. That's usually something that doesn't happen any later than September. Given how much rain we've had recently, I don't think there'll be much of a problem this year. But down in California, those, especially central and southern California, those offshore winds often don't even get going until September and can continue certainly into October, and in Southern California well into November, December, and even January. So a different story there. East of the Cascades, we haven't had enough water yet to end fire season, and in fact we're actually seeing very active fire conditions right now in that region. So there will be some precipitation Here you can see it, but it's more patchy. It's scattered showers and thunderstorms, so the fire activity remains quite high across Idaho into Utah and Wyoming as well. Northern Nevada really isn't going to get much, if any, precipitation from this event, so fire season will continue in the Great Basin this year, partly the legacy of that abundant growth of grass in the desert region following two good water years. So that's the big picture. If I move slightly, take a wider view or slightly, maybe not a wider view, but a different view of the Southwest, you can see conditions are actually pretty hot and dry across Southern California. Some fire activity, I believe this is the Coffee Pot Fire in the Southern Sierra Nevada, and a fairly active monsoon-like pattern across much of the Southwest. So the next thing I wanted to show is sort of where this pattern originates. And if others have remarked, this is once again a very unusual August weather pattern. In fact, we're probably breaking some daily records for the coolness of the upper level air mass near the Oregon-California border during this event. So and for the depth of the low pressure system. So certainly not record breaking for autumn or winter, but again, it is August, and so it is unusual. But I want to offer some context for that in a moment. First, let's trace this backwards. So this is an analysis from the European Model Ensemble. This is looking back in time. So this is going back to Tuesday of this week. So today is Friday. This is from Tuesday the 20th. And you can see this doesn't go quite back far enough, but I'll bring out my drawing tool again. You can see this deep low pressure system here. This originated actually as a former typhoon down in this region. So this, once again, a recurving typhoon is affecting California weather at an unusual time of year. Repeat viewers may be familiar with this story. But if I advance this forward in time, what you're going to see is that remnant low is not what's making it to California, but instead it pumps up a strong ridge over the Gulf of Alaska to the west of California. Now I'm toggling back and forth in time. So this is forward in time to present. This is back in time going back to Tuesday. You can see, and the region I think it's interesting to watch is this region here. Let me make that stick around for a moment. If you watch this as we advance forward in time, it pumps up this strong anomalous Gulf of Alaska ridge. And what happens here is you can see that there is, of course, this is quite a strong ridge. This is a 600 decameter ridge. So in other words, this may well be a record-breaking ridge over the Gulf of Alaska, but a record-breaking low-pressure system off the coast of Oregon. And these are causally related. So what you have essentially is in the upper atmosphere, you have strong flow in this direction. So flow in the anticyclonic direction over the Gulf of Alaska, that's forcing this air mass to come southward along the west coast to an unusual degree. So what we ended up having was a typhoon last week way down here that moved up, the remnant low moved up into the Kamchatka region, pumped up this ridge of high pressure here, induced this unusual flow pattern for August, which is now producing a pair, and this is also indirectly responsible for what happened last week, or earlier this week, excuse me, with this low pressure system near California. All in all, a pretty interesting setup. It's kind of unusual for this effect to be so profound in summer, something we might expect to see in autumn or spring more in those transition seasons, but ultimately this is the low of interest. And as we move this forward in time, so this is the present, almost up. This is the present. This is where we are now with the unusual showers and some thunderstorms in Northern California and the Pacific Northwest into tomorrow. And then this low slowly weakens and moves into the Great Basin. It won't bring much precipitation there. Before 4 or 5 days from now, relatively stronger ridging may develop across the Pacific Northwest. And so this is 6 days out. We have actually now the opposite pattern. We have a strengthening ridge along the west coast, strongest up in British Columbia, I need to go back to a slightly earlier tool here. I got to go back here all the way to earlier in the day. Okay, so this is about a week out from now. We see a ridge builds actually over the Pacific Northwest, so less so over California, although this is still a much warmer and less unsettled pattern as we go toward the end of August. And potentially as we go into early September, we actually see a stronger ridging pattern across all of the West Coast, so including California and Western Canada, a more pronounced period of ridging here with weak troughing potentially in the Gulf of Alaska. So almost the opposite pattern that we're currently seeing with a ridge over the Gulf of Alaska and a trough along the West Coast. By early September, seeing the reversal of that with a ridge along the West Coast and a trough offshore. As you would expect with this pattern, this is likely to bring renewed heat wave to much of the West Coast, although notably maybe not as much California in this case, or at least not the coastal California, as the Pacific Northwest and Western Canada. So this would actually be quite an extreme heat event potentially across the interior Northwest and Western Canada, merely warmer than average across much of California and the Southwest. So still a major change from the present pattern. But what the good news is this is the region that's just gotten a bunch of precipitation this week. So the fire risk, at least in western Oregon and Washington, will be relatively low. It may again be quite high in eastern Oregon, Idaho, Nevada. Another reason why I don't think fire season is over. But if I zoom in a little bit on this map, or actually more than a little bit, on the west, I want to show what the total precipitation from this pattern might be. This is again an ensemble average. That is a respectable summer rainfall, any way you slice it, across this entire region, essentially. So that's a fairly impressive, and that does include, as I mentioned, about as far south as Mid-Mendocino, and about far south as maybe Lake Oroville or so in the northeastern foothills. This portion of California is going to get a pretty good soaking. North Coast, look at that. 2 inches of rain potentially. Not bad. And this is why I think that for coastal zones in northwestern California and western Oregon, I think this might be it for substantive fire season. But it also tells you why in this region of California, I do not think it's going to do much, if anything, to ameliorate fire season. So in this region, which is essentially the part of California that tends to have a more substantive autumn fire season anyway, I don't think the upcoming pattern really changes the big picture of above average fire activity this autumn, so September through November expected. I do think what this might do is short circuit fire season up in this portion of California. I think that it's much less likely we're going to see major fires in this part of the state moving forward. But as you know, really everywhere from about the I-80 corridor southward, maybe even a little bit farther north of that. So I don't think this will end fire season in southern Mendocino or Lake County or Lake Tahoe region. So there's a pretty sharp cutoff between places that'll get soaking rain and just sprinkles. As you can see, there is going to be a band in this region. So this is around the Interstate 80 corridor from about San Francisco to Tahoe, that could see at least some brief light showers with this pattern today and tomorrow. Not a season-ending or soaking rainfall, but at the very highest points in the Sierra, we're talking places maybe 8,000 feet or so or higher, could even see a few snow flurries or a dusting of August snow on the summits of the mountains in the Sierra from this relatively cold system this weekend. And just to show how cold the air aloft is, it will of course be cold for August in August terms at the surface as well. But if we look at the 850 millibar air mass, if this was winter, this would be an extreme cold event because we see that there are some spots in Northern California where the air, again, this is not the air at the surface, but the air well above the surface is very solidly at 10 to 15 degrees centigrade below average. Just be very glad we're not having a 10 to 15 centigrade above average heat wave, because that would be an entirely different story. So we're getting lucky, you know. This is a highly anomalous event for August, and it's an anomalous event that actually is having mainly positive effects. So it's nice to be talking about that for once. As you can see, this will last for a few days before fading away, and then warmer than average temperatures in the atmospheric column once again return, especially across the Pacific Northwest, but also across California. So we're not done with the heat yet. It will likely resurge in September, but it is nice to get this break, this major break right now, and more importantly, some precipitation at the moment. But I've been getting a lot of messages and questions from journalists and emails into my inbox. Okay, so we're getting this extreme cold event, so this must cancel out the early part of the summer, right? Wrong. I could say that without even looking at the data, but now that I have looked at the data, I can say it more confidently, and I want to show you exactly the degree to which this is the case. This is a map of the relative anomalousness, or the unusualness of temperatures over the past 60 days for the western United States. This is from the Climate Toolbox webpage, which is a great resource for real time, or nearly real time. This is up through August 22nd, which is yesterday, so functionally this is real time. Anywhere that is in red is near or above the number one rank, essentially meaning that anywhere in dark red, the temperatures from late June through the present are still, if you take the average over the whole period, the warmest on record. That still includes, even if we include the summer temperatures up through yesterday, the vast majority of California, Nevada, Arizona, and then also parts of Oregon, Idaho, Utah, and New Mexico. So even with the recent cooler weather, even with the very cool weather that's coming, parts of California are still going to have experienced their warmest summer on record even after this system moves through. Now, do I think there's going to be as much red on this map in 5 days as there is today? No. I think that we're going to erase some of the red in this region for sure. But most of California is still going to be in the deep red. The rest of the Southwest is still going to be in the deep red. And it's not like in Northern California, for the most part, this is going to make for a cooler than average summer on average. It just might knock a lot of regions out of the number one rank. Now, interestingly, there are some pockets. So if you look certain parts of the north coast up here, along the immediate coastal areas here, although the data is sparse, and then again, a pocket along the central coast, and then in coastal Southern California, there are regions that have not experienced a record warm summer, and not even necessarily a particularly above average summer. This region was near or even slightly cooler than the long-term average, or at least the recent average, which is a bit remarkable in its own right, given that most of the rest of the entire region saw its singularly hottest summer on record. So as usual, your mileage may vary, and I do think that there are pockets up here especially where they're going to lose that number one rank as a result of the cool weather this weekend. But by no means does a few days of even very anomalously cool temperatures, even record-breakingly cool temperatures, although, to be fair, I do not think we're breaking any surface temperature low records for the most part, except for some localized ones. Even with this event, does not negate weeks to months of record-breaking heat in the months prior. And that is true in terms of the effects on the landscape as well, in terms of the accumulated drying effect and fire risk in many regions. Although, of course, the precipitation we're seeing up in this part of California does actually help ameliorate that, as well as up in western Washington and Oregon. So in places south of where we're seeing significant precipitation, we're still dealing with the legacy of this record hot summer, and that's going to continue to play a role in fire season going into autumn. One other thing I wanted to mention, this is a little bit difficult to see for some folks. I'm going to zoom in some more. You'll see more pixelation, but perhaps it's a little easier to read. Cut off the color bar. But anyway, reds and oranges are above average and blues are below average. There is a nice blob now of warmer than average temperatures along the immediate west coast from about San Francisco northward and going way out into the Pacific. This is because this recent storm activity has killed off the typical northwesterly flow and the upwelling. So there's a patch of cool water near the coast of Central California The Southern California Bight, which you can't really see, is warmer than average. There's some high humidity and dew points along the Southern California coast, including the San Diego area, as well again along the coast of Northern California. The other thing you can see too is that La Nina finally is developing. So there are finally now some cooler than average temperatures in the eastern tropical Pacific. Not a full-fledged La Nina officially yet, but what you can clearly see is El Nino, the warm blob in this part of the Pacific. It is gone. It is no longer present. Goodbye, El Nino. Still expecting a La Nina event of some magnitude by this winter, although it's not entirely clear how strong it will become. All right. And then there's one other chart I wanted to show folks before you're going to see my face again. Take a sip of water here. This is a current prediction of the 500 millibar geopotential height anomalies from the Grand Global Ensemble. The Grand Global Ensemble of Seasonal Models. This was updated a week or so ago for the remainder of the autumn. And what this shows is, well, unsurprisingly, in our climate-changed world, just about everywhere is going to see above average geopotential heights. But the more interesting question is, are there certain regions that are more above average than others? Because if geopotential heights just rose uniformly everywhere, the weather patterns would be hotter, but would otherwise look largely the same as they did before. But if the pattern of geopotential height anomalies is non-uniform, that might tell us more about the types of weather pattern that we're likely to see. So in September, what we see in the seasonal outlook is a broad region of amplified geopotential heights across sort of the mid-latitudes over North America. So there's just this big red blob that's kind of zonal or longitudinally or latitudinally oriented, I guess. So like a belt, like a longitudinal belt. There's a region of slightly higher heights off the coast of California and lower heights up in the Alaskan and Canadian Arctic. But generally, this doesn't tell us that much about a spatial pattern. It's just uniformly warmer than average. But if we step forward in time a little bit for the predictions for October, we start to see a little bit more structure to this, and we actually see that there is a bit of a local maximum over California and the Southwest relative to out over the Pacific. So what this is saying is that there's a region up here with not very above average heights, but that there will be a local maximum, perhaps, of above average heights, again, spread across a lot of North America, but at least in an eastern Pacific context, if you draw a box like this, the heights are higher over California than to the west. And if we step forward even further into November, again, it's kind of uniform, but there's a little bit more of a blob over the southwest. We get into winter, we start to see very strong signal for major ridging in the Gulf of Alaska, which would be kind of a classic canonical La Nina type pattern. And you can kind of see why this is a bit tricky for California. This is one of the reasons why the Pacific Northwest tends to see active, wetter conditions in a La Nina winter, because the canonical high directs cool, wet storms from the northwest into the Pacific Northwest in this region. But in California, it's kind of a subtle situation, because what you end up seeing is you have this northwesterly flow, and this kind of a question, an open question, depending on exactly the axis. Does the Gulf of Alaska high, is it centered here, or is it instead centered here? Because in option 1, that potentially opens the door to cool, not necessarily super moist, but cool and unstable air masses diving southward preferentially, bringing better snowpack conditions. But if it sets up more in location 2, that's sort of the ridiculously resilient ridge. That's a pattern that would redirect storms over the ridge and to the east of California, allowing for a dry winter. So this is one of the reasons why I'm highly confident that this general pattern will end up being true. That there's going to be an anomalous blobby ridge somewhere over here and a relative weakness in the height pattern here. But the question is exactly longitudinally where do these set up? And for California, of course, that's hugely consequential because shifting that ridge east or shifting this low west means that California is right on that razor's edge. And this is why seasonal prediction is so difficult, especially if we don't have a strong La Nina event this year. California will literally be, as it often is, on the dividing line, sort of active conditions to the north and east and inactive conditions to the southwest. But if that line is here, that's active in California, and if the line is here instead, that's a very dry winter. So, not really making a strong prediction about winter. But the one prediction I will make, and this brings about the next chart, is regarding autumn. Autumn is likely to be much warmer than average, and I know it may not feel like it. It may feel like fall is here early now, with the unsettled, cool, and damp conditions, but there is no indication of an early fall in a broader sense. In fact, if anything, there's still a tilt in the odds, albeit a modest one, since we don't usually get very strong tilts in the odds for precipitation, for below average precipitation across much of the interior west and southern and central California this autumn. So this is showing a 40 to 50% chance of precipitation in this region being in the lowest third of the typical autumn distribution. So this isn't saying merely below average, but it's saying in the driest third of autumns, which the driest third of autumns in this region is pretty much no precipitation. So there is a tilt in the odds still towards drier than average conditions from about the Bay Area southward in California. No strong signal for the Pacific Northwest or Northern California. As we go into winter, we kind of see a bit more of a La Nina-like signal. Again, I don't think that we should read too much into it yet, but this is a pretty canonically La Nina-like signal once it loads with precipitation odds. Well, actually, I should show the terrestrial summary instead here, showing again sort of a wet tilt towards wet conditions in the Pacific Northwest and tilt towards dry in the Southwest. This is a classic La Nina pattern. Right now, still not quite clear how strong La Nina will be. We'll see if this happens. If this happens, we'd likely see a reemergence of drought across much of the Southwest. But for now, let's focus on the autumn. And there is one other piece I wanted to show again, which is the lower atmospheric temperatures for autumn. And I'm going to zoom in here once again on North America. Bear with me. And again, we see a blob of much warmer than average temperatures across central and southern California and the Southwest, but also broadly. Nowhere are there below average temperatures. Only if you're up in Alaska might it be near average. But again, this is for September through November. Looks like higher odds of a warmer than average autumn and possibly also a drier than average autumn across the southern two-thirds of California. In other words, fire season is not over yet. In fact, it may not really have even peaked or gotten close to the peak in central and southern California in the Santa Ana and offshore wind-dominated regions, where we tend to see some of the worst fire risk in September and October when those strong, drying offshore winds coincide with warm, dry conditions in that late season period. That's still ahead. No indication that that won't happen. In fact, if anything, there's a stronger than usual indication that it will, with a weaker than usual indication for rainfall in southern or central California that would short circuit that prediction. So it could still happen, but right now there's no indication of this pattern, this highly anomalous summertime rain and cool pattern across Northern California continuing beyond the next 3 or 4 days. And in fact, it looks like those conditions will likely reverse thereafter. So you're going to see my face again. And I'm going to return to the comments so I can read yours. So again, quick sip of water, and then I'm going to dive into the questions. All right. Well, the first question is kind of a general one, although in the spirit of offshore wind season, it's an important one, so I will answer it. The question is, why do high pressures make it hot? If heat has a tendency to rise, wouldn't rising air create a low pressure system? It just feels like a contradiction in meteorology. Yes, it does feel like a bit of contradiction, but there's a reason for that, and it turns out that it makes a little bit more sense if you think about it in the vertical sense rather than the horizontal sense. Typically, all else equal, hot air near the surface does lead to low pressure, and cold air near the surface does lead to high pressure. In fact, we tend to see this in the form of thermal lows. So the desert Southwest, particularly the lower Colorado River basin, that sort of empties, well, whether or not there's water in the river is one question, but whether the air mass essentially draws upon very hot, humid air from the Gulf of California. So again, that body of water between Baja California and the contiguous portion of Mexico, that thermal low, that low pressure system in the lower levels of the atmosphere, does develop during summer when it gets extremely hot in the desert Southwest. So there is a relative region of very hot air and rising air, in fact, throughout the atmospheric column that does lead to low pressure development there. It usually doesn't mean storms because it's a very stable air mass, except occasionally during the monsoon. But you do tend to get the development of a thermal low there because you have air that is hot and it rises, and air has to essentially inrush from the sides because air cannot rise vertically from the ground. It has to come from somewhere, and therefore to fill the void, it has to come in laterally from a horizontal direction because you have rising air and has to converge to meet it. But when that happens, it tends to decrease the mass of air. And by the way, surface air pressure is literally a measure of the mass of air in the column above your head. So when there is high pressure, there is literally slightly more mass of air above your head at that moment than when your neighbor 500 miles away is experiencing low pressure. It's something that it's enough of a difference that some people, this is the people sometimes joke about their arthritis and weather changes, but there actually is some physics there. It does seem like certain human and other animal organisms and their body systems can detect these relatively subtle changes in pressure on the order of less than 5 or 10% total change, and yet we certainly can feel it. But that's why. It's because there's literally less mass of air in the column above your head during low pressure, and more mass above the column above your head when there's high pressure. It just varies. For perspective, the very strongest hurricanes on Earth might have a central pressure of about 900 millibars, and typical air pressure is commonly around 1,000 or around 1,010 millibars. So the very most extreme variations in air pressure from place to place across the surface of the Earth are on the order of about 10%, and usually it's much less than that. Usually it's on the order of no more than 2 to 5% variation from day to day or week to week in a given location. But that's enough that you can notice it. Anyway, that's a bit of an aside. So the intuition about hot air at the surface rising and causing a surface low, and cold air at the surface therefore sinking and causing convergence of that air at the surface is actually correct. This is why across the Great Basin in fall, in fact, in the wake of cold fronts, with cold air masses behind them, we tend to get surface low pressure. So not when the low pressure itself in the middle atmosphere moves through and brings the storm, but in the wake of that low pressure, when the temperatures near the surface get cold at night and you have lots of longer nights over the Great Basin, and that those clear skies are radiating a lot of energy out to space, the surface can get pretty chilly, sub-freezing in autumn across the Great Basin. Well, you tend to get surface high pressure following those low pressure systems precisely because it's cold at the surface, and you have that air converging downward toward the surface and resulting in air that kind of needs to escape by moving outward laterally, but it doesn't do so quite fast enough to avoid a temporary partial accumulation near the surface there. That is actually one of the main mechanisms by which we get offshore wind events and Santa Ana wind events and Diablo wind events in autumn. It is because in the wake of these autumn-like systems, cold air near the surface of the Great Basin actually results in a high-pressure formation near the surface, which drives a contrast between the high pressure over the Great Basin and the lower pressure in comparative terms over the California coast, because it's not as cold. In fact, sometimes it's quite warm under those patterns. And so you have that high to low pressure gradient. Wind tends to blow through those coastal gaps near the surface. You get a gradient wind. Voila, you have an offshore wind event. So that answers why the intuition is actually right, but then why, when we're talking about ridges of high pressure and troughs of low pressure, does the opposite usually occur? So in July, for example, we had a record hot summer. We also had a record strength ridge of high pressure over California, so that would seem to be the opposite. Well, it all has to do with the level vertically in the atmosphere that we're talking about. Ridges of high pressure we're generally not talking about surface pressure. We're talking about geopotential heights, which is related to pressure, but it is instead related to pressure primarily as measured halfway up in the atmosphere. So say the 500 millibar level, if the surface pressure is around, rounding 1,000 millibars, 500 millibars literally means half of the mass of the atmosphere is above you, half of the atmosphere half of the mass of the atmosphere is below you. So you're about halfway up in the mass-weighted atmosphere. It means you're very high. You're tens of thousands of feet up in the air at the 500 millibar level. So when we talk about these ridges, we're talking about pressure anomalies thousands and thousands of feet above the surface. It is possible to have sometimes what's called a baroclinic atmosphere, where you actually might have a surface low, so essentially low pressure at the surface of the atmosphere, which might be created, say, by a thermal low pressure system over the southeastern California desert in summer, created for the intuitive reasons we've been talking about, but you might actually have a ridge of high pressure overall. And what this means is that while the total column mass, the surface pressure, is indeed slightly lower than usual, so there's slightly lower mass in the atmospheric column than usual overall, that's mainly driven by the pressure in the lowest part of the atmosphere closest to the surface, where it's very hot, driving the column average. So you might actually have higher than average pressure at 500 millibar level, but lower than average pressure both at the surface and throughout the column on average. So it's actually yet another case where if you focus too much on the average, you might miss the point. So you can get a condition with a surface low and an upper tropospheric high pressure system, which is not uncommon in cases of thermal lows in summertime and ridges of high pressure atop them. And the reverse can sometimes occasionally be true in winter, although you can get alignment of low pressure surface at the surface and aloft if every part of the atmosphere is doing the same thing. But if different layers of the atmosphere are behaving differently, you can actually get a surface low, for example, and an upper ridge in the same place at the same time. And I think that is what explains the counterintuitive piece here, which is that we're really talking about different vertical levels, is the short answer. The long answer, of course, being what I just gave you. So it's a good question, and it's actually a timely one because it explains why California often sees the weather it does or does not in the autumn. Apologies, I think you're hearing a sawzall from the neighbor's construction site at the moment. Maybe the audio is getting filtered out, but we'll see. All right, it just stopped anyway. Okay, some ongoing comments. Ocean-kissed air, and I think HMB is probably Half Moon Bay. Heat coming Monday, that sounds about right. Cool, even drizzly conditions next 24 hours, which is nice. Does look a whole lot hotter next week, though, with nothing extreme, I don't think, heat-wise, but it will feel dramatically hotter because it will be a good 20-25 degrees hotter in some places next week than it is this week, with the return of 100-degree weather in the Central Valley, probably. Marty mentions it's been quite windy these past few days with no red flag warnings. I don't know exactly where you are. There have been some red flag warnings across northeastern California and the eastern Sierra and the Great Basin, where there indeed has both been windy and there have been fires. Red flag warning takes a few things into account. One is the humidity. So it's been windy but not super low humidity, which helps mitigate the risk. And in some places, the vegetation moisture has been a little higher with that higher humidity. So it doesn't mean the fire risk is zero or even low. It just means that it isn't especially high. But you can still see wildfires break out under non-red flag conditions. So I think that largely tells the story there. A comment that coming back from Crescent City that it rained heavily there, and then south at Blue Lake, not so much. That sounds about right with the pattern so far. There's a comment from Damo that mentions, is it true that the Earth's surface is warmer and simultaneously the very top of the atmosphere is colder due to the GHG or greenhouse gas effect, I assume, resulting in stronger storms since the differential is now greater? There's two pieces to the question here. The first piece is absolutely correct, that the surface of the Earth and the lower atmosphere, of course, meaning most of the troposphere, the layer of the atmosphere where most weather occurs, up to about 30,000, 40,000 feet or so, that is warming, of course, due to global warming. And that's the layer that we experience because we live in the lower troposphere. So if the troposphere is warming, the air that we exist in and that most storms exist in is warming. It's also true, though, that if you go high enough up in the Earth's atmosphere, that climate change and the accumulation of greenhouse gases actually lead to cooling, net cooling. So the stratosphere is cooling due to global warming. And that is partly because the atmosphere itself expands as the lower levels warm. So as the very uppermost atmosphere in the stratosphere, which again is a layer above the level at which storms occur, the stratosphere is in fact cooling because it's being pushed to higher and higher altitudes, and therefore the radiation that it's losing to space is happening more and more easily. So you can actually get cooling as that stratosphere is literally a little bit higher and cooler and closer to space than it once was. So you actually have diverging effects. Now, the second piece, does this strengthen storms? The answer is essentially no, because storms almost exclusively exist in the troposphere. So they only exist in this layer where the atmosphere is essentially just warming. The interesting piece is that the atmosphere is warming even in the troposphere, though, at different rates at different altitudes. So it's the closer to the surface you are, the faster it's warming. That's bad news for us, but it does mean that on average, the lapse rate of the atmosphere is becoming a little bit weaker. So the rate at which temperature decreases with height is well, actually, I should rephrase this. There are pockets where the lapse rate is decreasing, but overall, the surface is warming faster than the upper levels of the atmosphere. And so the changes in the vertical profile of temperature in the atmosphere can affect storms and precipitation. But it's not quite so simple as the surface is warming and the upper levels are cooling, because those upper levels that are cooling way up in the stratosphere are so high that they're largely irrelevant in terms of the kinds of storms that we have on Earth. Perhaps if we lived on a different planet, the stratosphere would matter more for terrestrial surface weather, but in that context, not so much. It's a question about turbulence in airplanes, which is a good question, but I think a little off topic for today, given we've got 5 minutes left, so I'll maybe ask that again during an Ask Me Anything session later. Yeah, there's a question about whether the rains in far northwestern California could essentially pull a Hillary, in other words, bring so much water in the middle of summer that it essentially ends fire season. I think up along the north coast that is possible, and maybe in a couple other pockets of far northern California. I don't think that'll be true once you get down to central Mendocino and Lake County, but north of there, maybe it will. And depending, if we get really lucky, maybe it even will up by Shasta area. Probably not so much south and east of there, although it will probably be temporarily mitigated for at least a couple of weeks anywhere where it rains significantly. But up in far northwestern California, I mean, based on what was already been received the past week and then what's coming again tonight and tomorrow, I think there's a pretty good possibility. Another mention that above 7,000 feet, there could be even a dusting of snow. That is true, although I would not expect meaningful accumulations, even at high elevations. I think the models sometimes will overestimate the ground temperature this time of year, so that wouldn't surprise me too much. Question from Mark about whether the hurricane that's moving towards Hawaii, just to be clear, Hawaii very unlikely to experience a landfalling hurricane and will probably pass south of the Big Island as a tropical storm. Will that cause any unusual weather along the west coast? It appears not. This is not a hurricane that's going to do the recurve thing that like Hillary did in pretty dramatic fashion last year. So these storms will not be doing that. And Central Pacific hurricanes are not usually the ones that recurve and affect the jet stream. So ironically, Northern California's weather is being affected right now by a tropical system, but it's one that was near Japan a week ago rather than one that's much closer to home near Hawaii right now, which is unlikely to have much influence at all. All right, and then one since we have 2 minutes, a question that's a little bit outside of the region, but I always think is an interesting one, especially now that I'm based in Boulder these days physically. Where does moisture for Rocky Mountain snow come from? The answer may be surprising, and it depends whether you're on the western or the eastern side of the Continental Divide. So there is actually a bifurcation along the Continental Divide, east of which most of that moisture, believe it or not, comes from the Gulf of Mexico, so from the southeast. West of the Continental Divide, most of that moisture does come from pretty much where you'd expect it to, which is the Pacific Ocean. And the reason for that is east of the Continental Divide, winds blowing from west to east are downslope winds. So they're warming and drying winds. Compressional heating leads to drying, and it's pretty darn hard to get precipitation falling east of the divide from storms that come in from the west. In fact, here in Colorado and Boulder, sometimes in midwinter, you'll see these raging blizzards, literally just 10 or 15 miles to the west. Over the Continental Divide, you can literally see the snow falling, but it will be warm, sunny, and windy, literally sometimes 65 or 70 degrees, because that downslope wind is so powerful that it causes those storms and that precipitation to completely fall apart over just 10 or 15 miles. So a major winter storm on the western slope of the Continental Divide usually does not make it east, even 10 or 15 miles east. So all that Pacific moisture, California coast ranges are the first thing that gets to benefit from that moisture. Then the taller Sierra Nevada, the western slopes wring out a bunch more moisture. One of the reasons why western Nevada is a desert is because it's largely in the rain shadow of the Sierra Nevada, although sometimes there's still some precipitation that can fall out, spill over. And then the Wasatch, the Basin Range, the Wasatch Mountains, the western slopes of the Rockies pretty much get rid of the rest of it. And by the time it gets to the east of the divide, that air is sometimes bone dry. You get 10% humidity, 70-degree temperatures, sunny skies mid-January. Because of these winter storms. So if there is going to be major precipitation and snowfall east of the divide, it's got to come from somewhere else. And the answer is you actually get a storm that forms over the western Great Plains on the lee side of the mountains and draws in a bunch of moisture from the south and east, which ultimately mostly comes from the Gulf of Mexico. So it is upslope flow is east to west flow east of the Rocky Mountains, and so therefore you need winds from the east to the west, the opposite of the prevailing wind direction, to get upslope flow and major precipitation. So for a big upslope snowstorm along the front range of the Rocky Mountains and Montana or at Wyoming, Colorado, or New Mexico, you actually want to be on the northern flank of a low pressure system, so that wind is curving from east to west, moving upslope, and then cooling and condensing as it ascends, rather than drying and warming as it descends the eastern slope. So Nevada might be wetter, by the way, if the dynamics were similar, but there you get a low pressure system that develops on the lee side of the Sierra Nevada, and there's not really any moisture source for it to draw upon, and so you tend not to see those big snowstorms upslope on the eastern slope. There are a couple of exceptions. You occasionally can get a low pressure system over western Nevada that somehow intrinsically has a bit more moisture than usual. It can give big upslope snowfall to places like Mammoth and Lee Vining on the eastern slope, so that Highway 395 corridor sometimes gets slammed under similar conditions. It's just that there isn't really as clear of a moisture source for those, whereas even though the Gulf of Mexico is pretty far away from Colorado, it's close enough that if the storm is persistent and big enough that it will get there. Nevada is a bit more of a basin. It is called the Great Basin originally for geological reasons, but it's also true to an extent from a meteorological perspective as well. All right, well, if there aren't any last minute questions coming in, I think I might call it a day right around the hour. Again, I'd remind folks that it is super helpful if you share the channel and the content here. Like these videos. For some reason, it's getting harder to share these videos outside of YouTube. I don't know if the algorithm dislikes external links these days or something, so good old word of mouth is still surprisingly effective and is helpful as I try and bring the channel membership up above 10,000 before the end of the year. So I think that's an entirely reachable goal, especially if you help me share these videos. So with that, I think I'm going to call it a day. Enjoy the rain if you see any. If you're in or immediately downstream of the Park Fire burn footprint, be careful, and if the Weather Service issues a flash flood warning for a downpour, do realize that it is a lot easier to get some flash flooding in a place that's recently burned than not. I'm not expecting widespread problems, but there could be some localized ones if a thunderstorm downpour sets up over that burn footprint, but otherwise, this is a beneficial weather pattern. It's highly unusual for August. It's rarely this cold and this damp in Northern California in August, so enjoy it because it's going to heat up again next week. And September does look hot still, despite this interlude of beneficial fire weather. I think that fire season may essentially be over along the North Coast and in western Washington and Oregon. It is decidedly not over, though, from about the I-80 corridor southward, and probably not over yet either in Lake County or southern Mendocino counties. North of there, some significant relief along the North Coast, probably done. But offshore wind season is yet to come, and the autumn does look warmer and possibly drier than usual. So I think that does set the stage for a second season, if you will, of fire activity centered more in central and southern California and along the offshore wind corridor zones later this season. So that's all I've got for now, and talk to you all next week.